Welcome to this video on Genetic System Builder, Walk Forward methodology. A lot of this is unique to GSB, but the principles applied here can be applied to any or most walk forward optimizers. So the first question is, why do we want to do a walk forward? The answer to that in summary is we want the out of sample results to be as good as the in sample results, and many of the clues to why a system is going to fail can already be identified by doing a walk forward, and it can stop you the painful experience of losing money. You don't want your trading system equity to sink like the Titanic, yet many of the clues in the case of the Titanic are also there in your trading system. In the Titanic, there was overconfidence. There was excessive speed when warnings had already been given that there was icebergs floating by. And walk forward will show you these same issues, whether they're present in your trading system or not. Any trading system or any boat can sink, but do you really want to sink when the situation was completely preventable in the beginning? Let's look at a trading system before we've done a walk forward. We can see the equity curve is linear, the out of sample result in green looks great, the performance metrics are excellent as far as the profit factor, the average trade, the net profit over drawdown. But let's look when we do a walk forward. The original equity curve is in green. When we optimize the parameters, we get the yellow curve. But if we were to trade the system without the wisdom of hindsight, we get the brown curve, a system that is unprofitable and lost us money should we trade it live. It is an oversimplification, but I could say that you could hope for the yellow curve, but expect the brown curve in your real live trading. So what exactly is a walk forward test? I'm going to briefly describe what a walk forward test is, but it is at high speed and perhaps missing a few more details if you're a complete new person to walk forward. In this example, we're going to have in-sample data from 1998 to 2001 as a in-sample period, and we're going to optimize that and see what the results are like in the out-of-sample period, which is roughly the year from 2001 to 2002. We are then going to apply the best parameters from the first run and apply it to the second run, which will give us another out-of-sample period. We're going to repeat this process until all out-of-sample runs have been done. The default is 10 out-of-sample runs normally in GSB. This has now given us an out-of-sample period from 2001 to 2008. We can see from the table that the first parameter was 4 as the best parameter which gave the best results, but that changed then to 6 and to 3 and then to 7, and at the end of the walk forward period, or the latter part, it became stable as a result of 6 being consistently the best parameter to be used. This process allows us to get an equity curve of what is in effect unseen data that the trading system has not seen. And how well this equity curve goes is critical to determine out-of-sample performance. Now, first of all, we're going to build some systems on GSB to show how to walk forward them. I'm just running with the default settings when you get GSB. I'll just run those by you. They're standalone ES, and the filters that we're looking at is tight, and what I mean by tight is we're looking for systems of particularly good performance metrics. So we're looking for something that has at least $80,000 profit, a Pearson's of 0.98, which means it's very close to a straight line, and we want a minimum profit factor of 1.9. On data streams, the defaults are ES for your data 1, and on data 2, there is your S&P 500 and your S&P 400 30-minute bars. Then I'm just going to hit Start and build some systems. You'll note that the CPU is driven fairly mildly, so I can run quite a few copies of GSB on this machine or other machines in client server mode. So we're going to leave GSB to run for half an hour or more, and it will start populating the systems in this unique system list here. Because we've got a very tight filter on the sort of systems we're looking for, it'll take it some time to find a system that meets our metrics, and then we're going to choose the best of those systems and walk forward them. We've now been running for 18 minutes, and I'm going to choose some of the best systems to walk forward them. I'm going to search on net profit drawdown, get the best ratio. Now this curve I don't like because it's got a flat period from 200 to 400 trades. The S&P right now is at record low volatility, and it's going flat during that period, which I also don't like. So I'm just going to go through this metric and pick a few that I like. This one here looks reasonable, and I'm going to walk forward that by right-clicking it. This one here looks good. It has its flat periods too, but it's still reasonable. That one there, it's a bit flat in the last, during this period here. I'd prefer something a little bit more linear. That one there is not too bad, but again it's flat as of late, which is no big deal, but volatility can't stay low forever. That one there I don't like. This one here looks excellent, so I'm going to walk forward that one there. That one there looks good. And the next thing, so I've chosen 4 systems here according to the net profit drawdown ratio. The next thing I'm going to do is look at the Pearson's correlation to a straight line, and basically the top systems here are going to be the most linear ones. Now that looks great. I do, however, know that the most linear systems aren't doing so well in the last year or so of performance in the S&P 500, but regardless, I'm still going to give that a go. And this one here is very interesting that the profit factor here is 3, so much less trades, but still nice and linear. Amazing less trades in the fact that it's only 328 trades, but I'll give that one a go just for interest's sake too. And we'll try maybe one more. That one there looks pretty good. So I go like so. Now the other thing I like doing is choosing the highest profit factor, and the 308 profit factor here we've already chosen. This one here, that looks like a okayish curve. I'm going to just look through a few more and try and pick maybe about 3 of each metric. I don't like that one, and that one there. Look, that's okay. That one there looks good. And I'm doing a walk forward of 100 generations and 100 population, which is a fairly fast walk forward, and it's not as thorough as I'd like, but at least we'll start with that, and then we'll see if the system looks good. We'll do it in greater detail. If I click on the walk forward tab, I can see there the systems that we're walk forwarding, and at a guess that'll take it maybe half an hour or something like that to walk forward all those systems. We're now going to look at one of the first systems, And this is a particularly good system. When you look at the performance metrics, they're good metrics. The equity curves are fairly parallel. The parameter stability is very high, that's 90. And the net profit is 96,000 in the original curve. The best curve is 109, so not a massive difference, but a significant improvement. And the out-of-sample performance is higher than what the original curve is, at 99,000. The amount of trades is fairly stable between all three curves. The profit factor is fairly similar between all three curves. Starting at 213 on the original curve, and on the last curve it's 2.2, so a mild improvement. And the out of sample, we always expect deterioration in an out of sample curve, but it's deteriorated very slightly. The parameters you can see are nice and stable, and we'll blow those up in a moment. It will always take a trading system some time to figure out what the best parameters are in the remainder of the data. So you can see in the first two runs, or three runs, that we have some parameters of 26 going to 16, and on the other side we've got 113 changing to 74. It is substantially different from the parameters in the remaining runs. But once it's in sync, you can see that we've got great stability here in parameters. There's been a shift from 38 to 36, which is just a minor shift, then back to 38, and we can see there's a 66 there, and then back to 86. But overall the parameters are exceptionally stable, and it leads another question is, how often would we optimize this trading system? Well, if the parameters haven't changed in the last 5 or 10 years, is there really a need to re-optimize it every month or every year after this? So parameter stability means the trading system has found parameters that consistently work, and hence there shouldn't be a great need to re-optimize this. This next curve is a classic and extreme example of a failure. Realistically, failures aren't often as clear and as extreme as this, which makes it more difficult, but here we can see that the final equity curve in yellow is looking great, and then when we look at the brown equity curve, it's sinking down. Realistically, we want the yellow curve and the brown curve to be roughly the same, but it will be normal for the brown curve to be somewhat below the yellow curve. There are some situations where it can be above, but that's not a common situation. Another thing we want to do is look at the amount of trades and the change between the various equity curves. So auto typically is in effect being trade date for the x-axis along here, but I'm going to change that to trade number. Now, as the number of trades are very similar, there's not a great deal difference in the x-axis and the curves, but I'm going to draw a possible scenario that can happen also in walk-forward curves. When we change the x-axis to trade number, this becomes a lot more apparent that in this case that I've drawn, the amount of trades has nearly doubled, but the profit is the same. So I would consider that a failure because the out-of-sample results are not probably profitable enough to be tradable, and also the fact that it degraded so much from the original equity curve means I would consider this a fail. It is possible that we don't have exact parameter stability, but the change in parameters make no or little difference to the equity curves. If that's the case, we'll end up having parallel equity curves, and we're concerned about the brown versus the yellow curve. That's the out of sample versus the walk forward current curve. And we also have some metrics that will help us search and clarify for these things. If you look at the screenshot there, you can see equity Bollinger Band 100%, So that means the two curves are within a Bollinger Band of each other. You can actually tweak the exact parameters under Tools, App Settings. The exact Pearson's and Spearman is not close, and that might actually be an issue with the current version of GSB. This is still quite experimental, but you can also see that the close settings for Spearman and for Pearson's are at 90% too. So that can give you an option to search on a large number of walk forwards that you've performed, just to quickly isolate what ones are likely to be the ones that are worth pursuing. So let's have a look at some walk forward results. Keep in mind these were very fast walk forwards. I've used 100 generations and a population of 100, and I would probably like to check this on using something like 300 by 300, but if it fails this terribly, there's no point doing a finer walk forward. So you can see this one here, the parameter stability is set at 72, the Bollinger Band is 100%, the other figures are 80, so they're quite good metrics. When we look at our parameters, you can see there's 82, 21, 82, 21. This one here has jumped enormously. The 34 and 14 is a big change from 82, 21, but we can see 82, 21 are very consistently the correct parameters from very early on. So that's actually a very healthy and a good sign. If I look at the amount of trades, you can see that it's got 450 in the final walk forward run, while as the out of sample is 548. A moderate difference, but that's still quite acceptable. And I would be happy with that as a pass, particularly because it's only done 100 generations and population of walk forward. But to be safe, I'll do a 300 on that later on. The next system here is interesting for a whole variety of reasons. If you look at the system, it's got an adaptive moving average, and we'll come to that in a second. So here we see that the brown curve is above the other curves, and the reason is that the amount of trades is 816 in the out of sample trades, while as in the best or current last walk forward it's 119. So this will become very apparent when we change the x-axis from date to trade number, and we can see a massive difference in the amount of trades. Now there's a whole host of issues here, and because of that I'm not going to say this is a fail, but I'm going to say this is one that I'm simply not going to look at, and we'll just go on to the next one. The other point I make, however, is that because it's got adaptive moving average, that's got 3 inputs, while as when you've got a normal oscillator, you've typically got 1 or 2 inputs, and if it's just a range, you've got only 1 input. So that would mean that the amount of iterations or generations and populations we need to do in a walk forward has to be much higher when we have adaptive moving average. The next one here, RSI. Well, this is a great example of a failure. So you can see that the equity curves that GSB made, the original one in green, it looks great. The last equity curve in yellow looks great, but the out of sample equity curve, particularly as of recent, is flat. So I would say that's a failure, and that's a system that you'd be happy to trade until you did a walk forward and you saw how poor it was. Here's another one. Well, I would be reasonably happy with that at a quick look. I know I see that there's 262 trades in the final walk forward, while as the out of sample is 445. So again, if I change the x-axis, massive differences. You could potentially revive this, but because GSB systems are so fast and simple to create, I'm just going to ignore it and go on to something that's better. How you could revive that system is by changing the fitness used in walk forward and or the slippage in commission used in walk forward. Personally, I don't feel it's worth the effort. Looking at this one here, well, the amount of trades is consistent. The profit factor out of sample has dropped a lot, but that's probably because the profit factor in the middle is poor compared to later. When I look at the parameters, I can see that we've got stability on the last two ones here. On this third one here, you've got a fair difference, but it is fairly stable. So basically, you've got a very stable parameter set along here, and then the markets have changed, and it thinks it now needs a change. So this would be acceptable because it's stable in general, and it's stable for the last two, but I'd probably be cautious and just say, let's go pick another system. I would prefer to see stable parameters for 3 runs, not just the 2 shown here. The fourth parameter shows very little sign of stability. I note also that this again is adaptive moving average, and I feel that we're going to need a lot more iterations to show a valid walk forward. And we're going to show later on what happens when you have too few iterations. This one here, well, that looks good. Again, we've got a big difference, however, in the amount of trades. And you can see that the profit factor in the final walk forward run is 434, which is enormously high. But there's a greatly reduced amount of trades, and the profit is actually almost as high. So this is one that you could do a fair bit more work on, but it's more complicated, and again I would probably miss it, but it's miss it and just skip onto the next one. But it's certainly not a failure, and the fact that you're getting such an amazing profit factor in your final equity curve is still a reasonably good outcome. So again, this is a fairly typical walk forward curve. Consistency in trades. Profit factor is reasonably consistent. You can see that the profit factor is increased in the final walk forward. It's decreased out of sample, but it hasn't decreased badly. Drawdown is fairly consistent. So I think this is a system that I like the look of. You can see here we've got 12. So there's been again, we've got like a two-stage set of parameters. These ones here are very similar. Then these last two have changed a fair bit. It would be possible to do something with the system, but I would probably just go on to the next one. This one here, this is an example of the x-axis blowout. It makes a lot more money in the out-of-sample curve because it's got a lot more trades, but the profit factor is reduced quite significantly, and the average trade has halved. So when we go to x-axis here, we really see how much that blew out. So again, I won't do anything with this. This one here, well, we're seeing again the amount of trades is very low in the last walk forward run. Things like this can change enormously when you alter the fitness, which we happen to be using net profit times average trade. And you can also skew a lot of these things by adding a fitness commission, and that can tend to make more trades or less trades depending on the fitness and the commission that you put in there. But we will stick with the default fitness, which is net profit and average trade. This next section is very much optional, but another thing that we can do in the newer builds of GSB is to optimize the data streams. Now if we look at our original code, we can see that we're using a data 3 for the first indicator, a data 3 for the second one, and a data 2 for the third indicator. Now we can make GSB go through all of these and work out what data stream is best. Now keep in mind, because we've got a total of 3 data streams, we've now given GSB 27 times more combinations, so we really need to increase the amount of generations and populations. So I'm using 600 generations and a population of 300. If we do anything less than this, I'm finding that the results are extremely erratic even if it comes up with the correct final parameters. So when we look at our walk forward results, we can see that the data stream has changed. So just to begin, to clarify again, it was 3, 3, 2 was the data streams. So now when we walk forward it, we can see it's 3, 2, 3. So this column here, where it says 38, 3, 38, 2, that 2 has changed to a 3, and this 2 has changed, sorry, that 3 has changed to a 2. The parameters look reasonably stable. They're not, I don't know if they're not quite as stable as what they were before. You can see the parameter stability score has gone from, I think it was 90 to 72. The equity curves look different as well, and to be honest, I don't like this equity curve because it's flatter in the last half of the curve, and I'd prefer a system that's more linear. You look at the original system and the Pearson has gone from 982 and the out of sample has gone to 964. So what that means is the equity curves are not as linear as they were in the previous example where we didn't optimize the data streams. So you don't have to use this feature. It's a bit experimental, but it's there if you're an expert and you want to play and you want to tinker. I'm going to touch briefly on the amount of generations and population that we do in a walk forward. As I said, 100 is okay for a fast optimization. If you use a value that's too small, typically what happens is your parameters aren't stable. The last results here might be the same as if you do lots more, but then the equity curves that you get in your out of sample are not going to be very accurate. So I typically will use 300 by 300, but may use 100 by 100 as an initial quick test. If we have increased the amount of indicators from 3 to 4 or 5, then we need to up this amount significantly. If we have a adaptive moving average, we need to up the amount of generations and populations more. Briefly, there's also the option to do a single threaded optimization. You would do this if you're low on RAM, or if you're running more than about 8 optimizations at once. It tends to be faster using single threaded than multi-threaded. The next option is also random space. What GSB does in its defaults is to optimize around the initial value within, I think it's plus or minus 25% above and below the existing values. If you use random space, it will optimize over the entire value that GSB has got stored internally. So if you had a moving average from 10 to 200, it might optimize from 10 to 200 rather than 10 to 30 if 20 was the middle value. I don't use that at all often, but it's an advanced option that you may or may not choose to use. I don't think there's a great need to use it. And now the more exciting bit is we can go to, Tradestation script. We don't click on optimization, we go to walk forward, and this will be using the parameters of the curve that we see here in yellow. And so we go to Tradestation script, copy to clipboard, and then we go to Tradestation and paste it in a strategy. Now I'm going to insert this on the chart. Making very much sure that I've got the bars back set to 500. And there we have it. Thanks for watching this video. Bye.